It's great to be here. I'm excited to present this material. It's kind of the opposite of a sales pitch for Lightstep, which I'm sure everyone will be grateful for. That's not why you came. Uh, I I think I hear a lot of talk about microservices in the industry in general, and I uh, I was inspired to make this the topic, partly to explain what it looked like when Google was doing things similar to this. And so I think a lot of the technology we're using harkens back to that era and that situation, and also to um, explain some of the failure modes. I don't think that we spend enough time talking about why it makes sense to adopt microservices and also therefore why not to adopt microservices, nor do we spend enough time talking about where things can go awry, and they definitely do go awry. So that's what this talk is about. I'm going to try to keep it pretty quick, and I love questions and even just full-on discussion between people who are here. I've looked at the attendees, and there are a lot of folks here who really know what they're talking about and probably should be on stage instead of me. So I hope that people will interrupt with questions or afterwards that we have a healthy discussion about this. At least that would be my ideal. But I'll get started, I guess. So this is what we got wrong, lessons from microservices at Google. So I want to start with the setting, like what was happening when we definitely didn't call it microservices. So let's get that straight first. But what was the situation? So, this is kind of how those guys looked at the time. They were selling a box that indexed stuff on your local area network and then allowed you to search it. It was a cool product. It didn't end up being as valuable as having a monopoly on all advertising, it turned out. But it was a cool product. Uh, and I joined Google right out of college. I was very idealistic at the time and was actually somewhat disappointed to land on the ads team, which I was like, wait, but I was supposed to change the world or something. It was a little after some of the track was laid that I'll be talking about here. I joined in late 2003, but I think I had some exposure to the people who were designing stuff in circa 2001 as my tech leads and so on. This is sort of like what motivated a lot of what happened at Google. Like, it was just really expensive to buy good hardware, like really expensive. And they were like, could we avoid the cost of like buying these insanely expensive, very reliable machines? And so they bought like really bad machines, like really bad machines. There's a story that is true, I think, that Urs Hutzel, who now runs a lot of infrastructure at Google as SVP there, but when he started, he was just doing kind of whatever needed to get done. And there's a story which I believe is true, which is that he actually dumpster dived at a RAM manufacturer and found like RAM that had been thrown out because it was broken. And then they wrote something to find all the sort of like sectors in the RAM that weren't healthy and just not use those ones. Like, they were really interested in cost cutting. So this was what they solved the sun problem with this problem, which is that these Linux boxes are really unreliable. And this motivated a lot of the design decisions at Google. It was about the fact that you're going to build highly reliable distributed systems on hardware that sucks and on an operating system that still kind of sucks, which it did at the time. And compared to Solaris or something like that, it wasn't nearly as good at the time they were making a lot of these decisions. And that motivated many of the design decisions that happened at Google. So this is something no one said in 2001. And this is also really important. This was what GitHub looked like in 2001. I don't mean that pejoratively, although I shouldn't say this on camera, but I went to OSCON, which is a lovely conference, and I heard someone at a booth saying, it's not Linux, it's GNU Linux. I'm like, guys, this is over. Like, this is done. But I love the GNU stuff is amazing, and Apache is an amazing organization, truly. But this was what they had to choose from. And what you will not find in any of this stuff is any of the sorts of projects you would need to actually construct a distributed system. They just didn't have them. So, I mean, Google had this not invented here thing. They really had no choice at the time. They didn't have a choice. And I think if they had had a choice, if Google had been founded now and, for some reason, from a market standpoint, that made sense. They should have started with GitHub and done the same thing everyone else is doing here. And I'll get to this later, but this led to a lot of the eccentricities of what happened at Google, I think, is that they started by inventing everything in-house, like everything, down to, they even had their own patch version of Red Hat 7.1 that they continued to maintain all the way into today, I think. So these were the constraints they had as engineers. You have to DIY, basically because of wacky requirements, like the scale that they're operating on was intense. They had to scale horizontally, i.e. you weren't able to buy a box that could scale as wide as was necessary for what they had to do. And you have to build on commodity hardware. This is very different than the sorts of requirements that I think we think about ourselves, especially if we're using cloud computing and so on. I think we understand that the Amazon instances will be replaced from time to time, but it doesn't feel quite like this. But this is, I think, the constraints that started things. From a culture standpoint, it's a very intellectually rigorous place. A lot of PhDs who had genuine knowledge. I think Google benefited greatly from the collapse of DEC, of digital, and the subsequent exodus from digital's research lab, like Sanjay and Jeff and Sharon Pearl, who actually was the person who introduced me to Dapper in the olden days. These people all came from those research labs, and they came over to Google. And I think it's just sort of, if you've got a hammer, everything looks like a nail. And these were world-class systems researchers, and they had a lot of intellectual curiosity and a background in distributed systems, and saw an opportunity to take advantage of that. And they were aspirational. They were thinking really big, and that continues to this day culturally at Google, which I admire. And they were maybe a little bit vain. I'm not thinking about a particular person here, but there's some sort of vanity in trying to do what they did. I think they succeeded, so good on them. But it was really ambitious what they were trying to do. So what actually happened? There was a Cambrian explosion of infrastructure projects in the early days of Google. I mean, this is an incomplete list, but some personal favorites of mine, like GFS, Bigtable, MapReduce, are all really well known. Borg is, I think, well known at this point, sort of a ancestor to Kubernetes. Mustang, which is actually really impressive. It doesn't really have a clear analog in the outside world, but it's their web serving infrastructure, the thing that actually does the brunt of the work for most web search queries. Smartass is I have a sort of a intellectual crush on Eric Veach, who created this thing. And when they launched Smart Ad Selection System, which is what Smartass officially stands for, they served something like 25% fewer ads and made 30% more money. It was just like an amazing achievement of machine learning. When people went and who were actual machine learning experts, well, Eric Veach is an actual machine learning expert, but when people from the outside came in, they looked at it and were kind of grossed out. It makes a bunch of assumptions and cuts a bunch of corners that make the system scale, but those corners are corners you can cut for this particular problem. And this is the type of stuff that happened throughout. Like in GFS, it's not really a file system. Like all the stuff you'd want from a local file system, it's not there, but it does support like multiple concurrent appenders of a single distributed file, which is really important if you're trying to have a lot of different writers appending to something. So had these kind of weird feature sets. I remember when I started at Google, I wanted to create like a shell expansion for GFS, and someone was like, "Oh no, don't do that. It's not like an actual file system. It's just call it Google File System." They were really smart about what they did and what they didn't do. So everyone there who didn't write those, which is almost everyone there, idolized these projects, like truly. I mean, I certainly did, as like a 23-year-old or whatever it was. And what happened is that we idolize these things. So we look at what's special about them, what's common. So they were designed to scale horizontally. They were factored out in the sense that RPC was factored out, service discovery was factored out, load balancing was factored out. Eventually, tracing and auth and things like that got factored out as well. You were programming kind of the business logic. And well, more or less, hopefully anyway. And then you incorporated your user space libraries to get a lot of the other functionality. And then we did, it wasn't totally CI/CD, but compared to what was common at the time, we did relatively frequent, scheduled releases. And this, in my mind, sounds really familiar. And this is like 2003-ish time. And microservices have these properties as well. Obviously, that's the subject of the talk. The reason that Google did all these things, I think, was different than the reasons why people should be adopting microservices now. And that leads to one of the major lessons that I've learned anyway, which I'll get to later. They did a bunch of stuff. I don't think I touched on this anywhere else in the presentation. So I will say the way they factored out this, what I'll call user level infrastructure. I mean, if you compiled a binary at Google, at least at the time I left, like 5 years ago or something like that, just a hello world, if you included the standard library, was like 150 megs or something like that. It's a big user level operating system that was compiled into every single process. And if you deploy frequently enough, that kind of works. I think the thing we're doing outside of Google is to move a lot of the logic into service mesh or something like that. I think that's really smart. And this is something that Google kind of got wrong. Like when we deployed Dapper, we would make changes to that base library. And within a week, like 50% of everything would be running it. Within 2 weeks, 90% would be running it. And within a year, like 98% would be running it. But that last 2%, these services were like never getting deployed and would be there really literally like for years, and they didn't die, and then you never got to redeploy your code. So I think it's smart that the ecosystem that we're inhabiting now outside of Google factors that stuff out, and that's definitely the right call. It does involve an extra copy, but I think it's worth it. Okay, so I'm going to get to lessons at this point. Are we all good? Questions so far? Okay, I don't see anyone. No one's mad at me.
Actually, I do have one question. What did you mean by factored out specifically?
Oh, yeah. So what I meant was that RPC, service discovery, all these problems are really hard. I think anyway, they're hard problems. And one of the things that upsets me a little bit about the world that outside of Google is that not everyone, but many companies, I think, appreciate simplicity, and that's good. Simplicity is good. But we end up writing kind of like REST APIs for very complicated services, and then we call them just using ad hoc mechanisms. And then eventually you have a failure, and you're like, oh shoot, I should probably write exponential backoff in case the thing isn't working. Okay, so you hack that into your own code at your service, and then you're like, oh well, like what if we need to like auto scale these things to have 10 times as many? Like, how are you going to discover them? And we end not everyone, but many times I see application software writing that logic at the same level as the application. And that's just like a really, really bad idea because the code is hard to get right. And it's not part of your application. That's part of the infrastructure. And so Google, I think, did a nice job of factoring that at just a simple API level, but everything was compiled into your one binary. And they basically deployed statically like binaries. That's changing a bit now, but at the time all this was happening, you deployed a statically linked C++ binary or one giant jar file, and that was it. So does that make sense?
Yeah.
Any other questions?
Do you have context as to like when Google started RPC or the journey around the discovery and load balancing? Like, are there solutions out there?
Context around when Google started things like RPC. So when I started, there's something called Client RPC, which was an RPC system. It was designed specifically for web search when it was designed, and it was good for that. It's very difficult to configure. It made a lot of assumptions about the topology of systems, and was frankly very daunting. They replaced that with something called Stubby, which then became Stubby 2, which then became Stubby 3, which is basically gRPC. And so, yeah, they've had some lineage of that for a long time. I think Client RPC dates back to 2001, I believe. But around 2000, I think 2004 is when Stubby was introduced, and that was the first time they had something that involved code generation and was actually kind of like had a good UI as a programmer. I don't mean the point and click, but it was a pleasure to use it. And I actually will say Google was very late to the game in pursuing any kind of message bus type of stuff. Like they weren't big on things like, I mean, not Kafka specifically, but something like Kafka. They had a pub sub system, but it wasn't very widely used. RPC, even when it didn't really make sense from an efficiency standpoint, the tooling for RPC was so good that people used RPC even when it might theoretically make sense to use something else. And that was really baked in at the base level, I think. Other questions? Cool. So lessons. So the first one is know why, and specifically to know why you're adopting microservices. We at Lightstep, we hosted some talks recently about dreams and nightmares of microservices. And Vijay Gill, who's the SVP of engineering at Databricks and was formerly at Salesforce and Microsoft and Google, gave a talk about the one good reason to adopt microservices. And I'm totally with him on this. I'll say there are 1.5 reasons, but almost always the reason to do it is that you want your engineers to be more independent and efficient. It's about independence of engineers. And that's what Vijay was saying, and I agree with him, is that you can't really get more than 10 to 12 people as engineers to actually successfully collaborate on software. It's just like a human communication thing. It's not a technology thing. So if you want to be able to have many hundreds of engineers working on one project, you have to split it into smaller pieces, and those become microservices. This is the good reason to develop microservices. It's about independence and efficiency of engineers, not about computer science and horizontal scaling, which I talked about earlier. And I think that a lot of my complaints about people imitating Google are that they're imitating the wrong thing. Like that microservices might make sense. The reason Google adopted them were I highlighted earlier are not applicable to a lot of companies that are adopting microservices. And I think we should be careful about why we're doing this stuff. So yeah, I think Google is sort of accidental microservices. It was really about computer science and unreliable hardware, and not about org charts. I think they sort of stuck with the pattern, but they were designing these for very, very large scale systems where they cared a lot about latency and a lot about throughput. And that led to a bunch of design decisions that there's always a trade-off between something that Jeff Dean used to say, which I thought is really smart and stuck with me, is that you can't really design any system for more than 3 orders of magnitude of scale. And the systems at Google were designed for scales that are not often seen outside of Google. That's not to say they're better. The systems are actually often very difficult to use or feature poor, but they scale like crazy because Google's doing, I think the published number is 2 billion RPCs per second steady state. It's actually a lot more than that, but that's a lot. So if you want to make something scale to that, it's not going to have a lot of features or it's going to be a nightmare to configure. And so that's kind of what they did. So what's best for search and ads is best for all. I designed monitoring systems at Google for the last 7 years I was there, and I had a kind of a minor nightmare in that I had to make search and ads happy or my project wouldn't get staffed. But if you make something that works for them, it's not a better or worse thing. It's just a different scale. Like the kind of knobs and configuration that search and ads need and Gmail and whatever are just so different than some random project that has like 5 devs working on some little back-end feature for something. But they also need to be monitored. And so designing systems that work across all these scales and being forced from a managerial standpoint to have one system that works for all scales is very difficult and challenging. This is more of what's true. I think things that were really scaled out, planet scale services benefited from the things designed for Google Search and Google Ads. But a lot of other things, it worked, it literally worked, but configuring it took a long time. There is this incredible video, which unfortunately I looked, but doesn't exist. If anyone here, an ex-Googler, recognizes this, but there is this amazing video inside of Google. It was called, "But I just want to serve 5 terabytes." And it was this cartoon that there's a website you could type in a script and then characters would act it out. And there's this character it was a platonic dialogue between this fox lady and a frogman or something like that. I can't remember, but they were talking to each other, and it's just him saying, "All I want to do is serve 5 terabytes." So it's too much for one machine's memory, but it's not like that much data. It shouldn't be a big deal. And it just goes through the litany of things you have to do to deploy something to production in front of live user traffic at Google. And it was really, really hard because they had this one size fits all thing, and most things weren't the size they were dealing with. And what I would say is that not all, obviously, but most companies outside of Google are more like these smaller services that were struggling with these tools. And there's a lot of emulation of Google's technologies and techniques that I think aren't very thoughtful. There are things they did really well for their scale and things that shouldn't be adopted. So lesson 2, is that serverless still runs on servers. I think we've got to remember this. Google didn't really do a lot in serverless. I mean, it wasn't called. This is my least favorite buzzword du jour, by the way, because I will list some things that are serverless, like peanut butter sandwiches, ducks, like water. I mean, it's anything that's not a server. It doesn't mean anything, you know. Like it just means it's not a server. It doesn't mean anything. But functions as a service means something. I think that's what people are talking about with serverless. Functions as a service is fine. So I'm not expecting you to all to read this. This is something that Jeff Dean wrote inside Google. It was numbers every engineer should know. Of course, like most engineers, I don't know them all by heart, but we really should. And it's just things like how many nanoseconds does it take to mispredict a branch on an if else versus how many nanoseconds does it take to read a megabyte from a solid state disk. And it's important to understand these things because they're like some things here are over 100 million times slower than other things, but we don't necessarily think about that when we're reasoning about the systems. This is a nicer version of it that I found on GitHub that, you know, you can all look if you want. But the two I'll highlight are these. Main memory reference is about 100 nanoseconds. Okay, so if you don't have it in the cache and you have to get into memory, it's about 100 nanoseconds. So a tenth of a microsecond. And a round trip, even within a data center, is 500,000 nanoseconds. So 500 microseconds is pretty fast. It's faster than a millisecond, but that's a lot slower than 100 nanoseconds. And the thing about serverless that kind of blows my mind is that, like, we can talk about stateless, and stateless is fine, but you do benefit from caching locally. Like, if you cache something in memory, you're paying 100 nanoseconds to retrieve it. And if you cache something in a different process, you're paying 500,000 nanoseconds to retrieve it. It's just like, it's totally different. It's a completely different deal. And so if you're lucky enough to have something where you can do all the computation locally and depend on no other processes, that's great. But that's kind of like those embarrassingly parallel MapReduces and things like that, which exist. But if you're trying to build a whole system on serverless, I think you need to think about caching. And Google did some experiments in this realm, and I just didn't think that they've really held water for general purpose application serving. They definitely have their place, and I think they're great for writing a hook that's going to run when something goes to S3 or whatever. I'm not saying serverless is bad, to be clear. I'm just saying it has its place. And I think it's very different than writing microservices, which often benefit from just a little bit of context between requests, namely in the form of a cache. And a cache is not the same thing as being stateful, right? It's an optimization, but it's a really important optimization. Does that make sense, people?
Yeah.
I feel like this is not talked about enough, and it drives me crazy. So, okay, good. Yeah, so I already talked about this. Caching is really important, and fast could be improved. I think the APIs could be improved to make this easier, but I think that needs to happen.
Can I ask you a question about that? So when your previous slide, you're looking at scale. It's a matter of what's the problem you're solving. So where do you draw the line where you actually care to optimize towards the main memory reference versus our data set's not big enough that we should even care about it at all?
Yeah, so in case it's not picked up in this video, when do you care about this stuff? Is that a short summary? It's a great question, like a really, really good question, and an obvious annoying answer, which is that it depends. But I do think if you're designing a system, it's very reasonable to ask yourself, to look this thing up. I mean, I haven't memorized these either, but to look this thing up and be like, okay, like what am I going to depend on to do this? How much memory am I really going to need? Like how, like roughly, not within a factor of 10, but within a factor of 1,000, how many requests am I going to receive? That sort of stuff. And if you can't answer that question, I don't think you should be building software yet. Like you should answer it first. I'm serious. You should figure that out. I remember I was designing a storage system at Google, which is a total failure, but I did it. And someone came up to me and they're like, they were interested in the system and they're like, oh, I want to use it. I'm like, well, how much data are you storing? And they're like, oh, a lot. It's like, well, like just ballpark it, And ultimately after he had to go back to his desk and look it up, it was like 100 megs. And like, that is a lot. I mean, I can't count that high, but like, it's not that much. Like, so I think people just need to ask themselves, I'm not talking about being precise, but just like within a factor of 100 or 1,000, how much data is this? How many calls is it? And if you answer those questions, you can look at something like this and be like, okay, like how many network calls am I going to have to make? And is that reasonable or not? And
But I guess specifically, it's knowing which architectural approach to take and how do you involve that in the software development process so that you're thoughtful about this before you commit to, oh, I'm going to optimize towards the 100 nanosecond direction when you didn't need to optimize towards that at all.
That's a great question. I will say that there are a lot of people at Google who optimize without needing to, so it's fair. So in terms of when to do it, I mean, I want to be clear, I'm not against serverless. I think it's actually really great. And I know a lot of people who are really smart, who are wise to use it. I just don't want it to be seen as an architectural choice to defeat all others. I would basically say do the simplest thing you possibly can if you can deploy quickly and find out if it works. If it's going to take months of development, I'd fall back on my like, try to think about it answer. But I'm all about simplicity. I'll talk about one other thing in a moment that I think is also important, but I don't know if that addressed your question.
It does, yeah.
Okay.
I have a good question. So for a lot of people who are just trying to ship the org chart, not really trying to optimize for latency or even anything else, just trying to speed up developer velocity, like why would they have to think about, I mean, I'm just playing the devil's advocate here, but why would they have to think about like some of these numbers or like any of these other things?
Just Cindy, it's good to see you. And why would anyone care about this if they're just trying to ship their org chart? I think that's a totally fair question. I mean, maybe I'd go back. If it's really such a simple thing that you kind of know what you need to do and it's going to take you a week to get it written, you probably should just write it. I'm more thinking about larger investments of time where it's just part of the design process to me to come up with some ballparks on how much it's going to take to serve this. I think otherwise you run a pretty likely risk of ending up with a system that is ill-suited to the task. And we all know what that looks like. I mean, I definitely have seen, I think Mongo is a great piece of technology for what it's good for, but it was maybe not intentionally over marketed, but I think used for things that it wasn't necessary, like for data sets that would fit comfortably in a MySQL instance. Like if it's going to fit great in a MySQL instance, you should just buy an RDS instance and put it in RDS because it's a lot easier to program than Mongo or something. You know what I mean? So it's more about just taking the time to think about how big the data is. I don't think that that's like an onerous thing, even for a simple, small project.
Like maybe another perspective to ask the same question is like, how do you justify to the business who's maybe trying to build a retail business somewhere that these extra time they're spending on these optimizations worthwhile for the business value that is being provided?
Steve's question is, how do you justify to a business owner who doesn't care about the why of the engineering, they just want to get the thing done, why we should care about this? This is not about optimizations to me. This is actually about avoiding a really profound failure mode. And that's how I would communicate it. I think pre-optimizing is really dumb. I'm not arguing for that at all. It's more like not building something blindly in terms of its requirements. Like if maybe to be more concrete, I think that this is a way to minimize engineering time and wall time. Because if you do this wrong, you have to start over. That's more what I'm trying to say. Like if a serverless thing was the wrong thing and it turned out you needed a cache locally, that means that you're delivering a terrible experience to the customer because latency is really high. If it's the right thing, you'll find that out in this analysis and you can just go and build it. Again, I'm not arguing against serverless. I'm just saying people should think about whether or not they need a cache or not. That's all. And I think that's a very reasonable thing from an investment standpoint. It's not really an optimization. It's more about just choosing the right technology for the job and not just doing what your neighbor did or whatever. Makes sense? Other questions? Okay. Where am I? So, yeah, so independence is an interesting question. I think I was talking about, this is something that did not happen at Google. So I guess it's something Google kind of accidentally got right. But we're talking about independence a lot and how teams should work independently. And I think that there's a version of that feels sort of like this. It's like this, everyone makes their own totally separate decisions about everything. This is like the most common failure mode I've seen in my current work at Lightstep in people deploying microservices is that they get the independence thing and then they tell every team of like 5 to 10 or less people, go and pick your own stack. And for building your service and serving your API, I think that's actually kind of reasonable. But the trouble is that you do have some cross-cutting concerns around security, monitoring, deployment, et cetera. And by having a very large diversity of stacks, you're in like a very bad place. And I see a lot of nodding heads. I think it's more like this, like, yeah, like every bee gets to go to their own flower and like do their own thing, but like they're all bees, like I think it's important to be somewhat disciplined about the technology choices. It doesn't have to be one, like there can be drones and the other two, whatever they're called, but just not like a totally egalitarian hippie thing. One odd thing for me is that I think a lot of people that I talk to, uh, there's sort of companies that are vaguely like hipster companies and companies that are vaguely sort of enterprise companies. And even though I think there's a narrative around enterprise adopting microservices later, which may be sort of true, they're actually much better at doing the bees thing because they have central control. In companies where everyone is making their own totally independent decisions, which is more common at really innovative companies where the engineers feel entitled to do that, you are more likely to end up in a place where every service is written in a totally different framework and language, which again, I think is a total anti-pattern. So I don't know if that resonates with people or not. Okay, 2 thumbs up. All right. What's up?
We're going through a similar transition with this, and we had a bunch of engineers that wanted to do the hippie way and do everything their own way. And we had to sell them that we were going to make the right way the easy way. And that was how we got people back into being drones. We said, we're going to take responsibility from you so you don't have to worry about this.
Totally. Yeah, that totally makes sense. And I mean, I think that the messaging of it is like a little bit tricky. Because I don't have a strong feeling at all about what framework it should be. And that's an interesting thing. Like I think I've seen companies do really well with Python and Go and Java and whatever. It's not about which framework at all. It's just to limit the menu. It should be a very small menu. And Patrick, I think that makes a lot of sense. What's up?
Yeah, I wonder if you think that the reason that sort of diversity of choices can get in the way, is it more about lack of common infrastructure or more about lack of common sort of institutional knowledge?
It's a really good question. So lack of infrastructure, lack of institutional knowledge. I think certainly both, but the thing that I observe more is, I mean, the institutional knowledge can be found on the internet to a certain extent if you're using a common framework. There are companies I won't name that are inventing their own languages, literally. I think that's a really, really, really bad idea. But unless, it's your company's purpose to do that, right? But I think that the common concerns, I mean, I'm super biased on this working for a company that does monitoring stuff, but it's really difficult to deploy effective monitoring across totally different surfaces. Even if you can get the data, making sense of it is really hard because you're comparing apples and oranges everywhere you go, and it's hard to level set. So I'm mostly thinking about infrastructure and common concerns around deployment and operation.
Yeah, so I work at one of these companies you're describing right now. We do a lot of acquisitions, and so by default, we're acquiring companies that are less or more mature, have better or worse tools, wildly different tech stacks, wildly different architectures, and then we want to make it so that the data is seamless across all these platforms, of course. So what's your recommendation in that situation?
Sorry. I will say I saw Google acquire a bunch of companies that seemed very lively when they were acquired. It wasn't like some sort of soft landing, like it was a strategic acquisition. And then they tried to just like force them, like do it our way. And like that wasn't super successful in some cases anyway. So I'm certainly not arguing for that. I guess it depends. I probably shouldn't even express an opinion, but I would say if I was put in that position, I would wonder whether we're trying to integrate this product into other products or if it's a freestanding thing. If it's a freestanding thing, I just sort of live and let live on the framework as long as it's working for them. If you want to actually have products literally integrate at the product level, which may be a requirement from a business standpoint, then I think it gets a lot harder because you need to have these, you can't isolate them from a resource standpoint. And I think a lot of the cross-cutting concerns come into play. So I guess it's a matter of building a bridge, but that's messy and I have no really good advice, unfortunately. I sympathize though.
Just to clarify this slide point, you said something about like Google kind of felt what they did correct by accident? What do you mean by that? Like they as an organization, people, teams are just kind of aligned by default?
Really good question. So yeah, I said Google accomplished the bees thing by accident. It really goes back to the fact that GitHub didn't exist in 2001. So by the time, if you were starting a new project at Google, it was really nice, like in the many ways. Like you booted this thing up and you got some really high quality system software for free. And people would often ask, oh, what language, who didn't work there, what language do you work in? Is it C++ or Java or whatever? And that was really less important than like the client libraries and stuff you had to integrate with. Like tuning all those things was way harder and way more time consuming than writing the code in general. And there's the whole joke about Google engineers are just like translating from one protobuf to another. That's like, it's very true. But you paid such an amazing tax to deviate from that no one did it if you're building from scratch within Google. I think acquisitions, that was often quite difficult. I think YouTube is still, as to the best of my knowledge, is still in some ways deviated from what Google's doing internally. But for new software written inside Google, what you got for free by using the one or two kind of sanctioned things was so significant that you would never consider doing anything else.
Would you say that's due to, so you said earlier that kind of built into the culture was this, like there seemed to be some agreement to work on these kind of epic infrastructure things. So it was there already. At what point did they, so it happened earlier than this. Do you think you can describe like what point in their company life cycle that was made?
To bet on this massive infrastructure stuff, you mean?
So somewhere along the line of like, all right, let's just build it because it would be like more elegant or be like the correct infinitely scaling solution. Then I mean, of course, once you have it, it's like, oh, well then it'll just work if you just do it the same way everyone else is doing, right? It's kind of like I'm trying to understand where like the cart or the horse, like which came first, sort of thing.
Yeah, I think that Google's decision to build their own infrastructure was by necessity and very, very early in the company's life cycle. I mean, a year or so in, I think they were already starting to do that. GFS is a very early project at Google for sure, and many other things that were in that era were also very early. I'm not sure if I'm going to properly address your question, but from the point that things like Borg and Bigtable existed, I felt like the die was cast. It wasn't much going back after that. There was too much stuff that you weren't going to build yourself if you were sane. And that was like 2003 or something like that.
Okay.
But I'm not sure if that's really answering your question. I'm sure that there were attempts at times to build things outside. That thing, Orkut, the social network that didn't like really work, I guess, as a product, but that was an interesting experiment. Or it was named after the founding engineer of Orkut, whose last name I won't pronounce correctly, but he was really interested in the .NET stuff, and that was an experiment. They built the whole thing on .NET, and just to see what would happen, to see if like they were making a mistake with their technology choices. I don't know what the moral of the story was there. So there were occasional attempts to try something different, but it was pretty rare. Cool. Other questions? I'm almost done. You're in luck. Cool. And the last thing I'll say is more true to like my current work, I guess. There's, the word observability, I'm sure, dates back before this. Cindy, do you know? You probably know this. When did people start using that word? Was it at Twitter? Or was it before that?
Twitter.
Okay, good. All right. Yeah. So when Twitter was having the fail whale, they wanted to build a system that was observable. I think Cindy literally wrote a book about observability. Is that accurate? Cool. You should buy it. The first thing people need to do is to gather the data. And I think people often assume that once you do that, you're done. And I'm here to say that you're not. I think, this is like a bunch of this is a bunch of graphs from a dashboard, and there's a regressions, pretty obvious in all these things. And this is actually from a real dashboard. There are many other graphs that show the same regression. the problem is that you did detect the regression, truly in many places, but it's really difficult, if not impossible, for someone who's not intimately familiar with the systems to figure out which one of these graphs is responsible for the issue. And I am of the opinion, and I will definitely clarify this as an opinion, but I'm of the opinion that observability boils down to two activities. There's detection of critical signals and refining the search space. The search space is very, very, very large in these systems that we're building now, and you don't want to refine the search space by visualizing all of it. I'm serious. I mean, quite sincere about this. I think it's not a good pattern. I also think it's probably unrealistic to have any solution that's literally going to root cause and remediate something for you totally automatically, at least for complex stuff. So in my mind, observability, at Google, when it was good, was about building systems that allow you to refine the search space really quickly. I wish it was a public talk, but Cody Smith, who is the kind of ran SRE for Google Search, had this beautiful talk he gave about SearchMon, which is like the simplest dashboard in the world. It has 12 graphs and 1 second resolution and just exactly the right dimensions so that you can explain variance really quickly and efficiently. And you don't wonder about what's going on there. It's just like a beautiful thing. And the number of graphs they could have generated was just absolutely dizzying, and they didn't do that. They generated a short list of things that were what you needed as a human being to actually understand and explain the variance and reduce the search space. So I think this is really important. I think that the industry is just kind of getting to the point where this is becoming a problem, but I do think it's going to be increasingly important as we are drowning in the signal that we get from our own systems. Yeah, so in closing, I think that there are two reasons to build microservices. One is computer science, which is much less common as a good reason, but is why Google did it, I think, initially. And the other is team independence. And just to know why you're doing it and to make sure that you're building team independence in a way that also doesn't create this like hippies versus bees problem. I think we have to think about appropriate scale. That's something that I saw messed up like at Google a number of times. Like we slowed so many projects down by forcing one size fits all when one of the sizes was like planet scale. And don't forget about the cost of network. I see people doing that all the time. And I think detection and refinement are what we should be thinking about when we're trying to make sense of these systems. So I think with that, I'm done. I just want to stop for Q&A, and then after that, we can continue to hang out and have drinks and stuff like that. Go ahead.
So talking about reasons for microservices, there's three that come to mind that I've heard espoused. One is partial scalability, so being able to scale one part of your system separately from the other parts. Another is hot deploy, with really fast sort of stop and start times. And then another is sort of a natural emphasis on decoupling that creates more change isolation. What do you say about those three things?
All sounds good to me. But I think the team communication thing is also pretty real, and I didn't hear that on the list. It's not really about the operation of the services, but it's about just the act of developing them. Like part of the beauty of it, I think, is that your org chart does map to your system diagram to a certain extent, and you only need to talk to the teams on either side of you if you're making changes. And I think that's actually really significant in terms of the efficiencies at scale for organization of engineers, not the system, but the organization building software. I think that's really important. But I'm personally, I would just come down. It's a common thread in all of those, but if you ignore the human factors, I'm mostly moved by the horizontal scalability of microservices, I think, because if you need that and you can't do it, then you're really in trouble. And I think they usually make it easier to do that, but I don't know. They're all great reasons.
So just coming back to the questions that we were talking about, which is like, how do you integrate very heterogeneous systems, which could be either the result of like different companies getting acquired, just different projects, sort of like taking root in different ways. In the recent years, one of the most interesting infrastructural paradigms that have emerged is like the service mesh architecture that was popularized by Latency and Envoy primarily, which sort of like, it doesn't completely solve the problem, but it helps greatly, is sort of my understanding. And it's sort of like being adapted across widely across the industry from what I can tell. So what are some of the thoughts about like the service mesh to sort of like use it as this crutch to get infrastructure from like a sort of like a really horrible place to something that is like, even if it's not this idealistic thing, something that's a lot better?
I'm definitely wildly in favor of it. I think it's unreasonable to expect, especially if you're integrating legacy components, you don't want to be forcing recompiles, which is, well, first of all, the service mesh is factoring all these hard computer science problems. You have two choices. You either do it in a mesh or you do it in a library of some sort. gRPC would be, I guess, and of course, gRPC and Envoy can work together, but gRPC would be an example of like the pure library approach. I think in terms of integrating legacy stuff or things that you don't control deployment for, Service Mesh just offers a lot more flexibility. It's certainly not a panacea, and I do think it's sometimes over marketed. It's great. Like I really think it's an excellent way to migrate a system towards something more modern, but it doesn't, out of the box, a lot of things that people expect it to do aren't going to work unless you also change the application software. I'm obviously think a lot about tracing. I think Service Mesh facilitates tracing, but without tracing within the application process, you're not going to get correct traces. So it's necessary but not sufficient or something like that. So I like it. I think it's great. People, I think sometimes are a little bit misinformed about how many problems it's going to solve at once, but I think it's like a fantastic way to bridge a legacy system into something more modern. And the only problem with it is this, in my mind anyway, is just extra copies of the data. You're making many copies when you don't need to. So someday in like 10 years, when everything's all stabilized, I can imagine it eventually going away in high throughput environments in favor of smart client libraries, but it's dumb to do that now. I think it would be better to focus on operational efficiencies, like, just deploys and stuff like that, make that easier.
Any other questions?
Okay. Go ahead.
So I imagine that I've been in a few situations like this where you're not building a system from scratch. You've got a monolith, you've got a larger system, and people get excited about the idea of breaking it down into smaller services to increase the velocity of the different teams and scale the system. People have lots of reasons for doing that. And a lot of the complexity and mistakes, I think, that I've seen relate to misgauging the granularity of the services that you should compose. You start with a system that usually backed by a relational database or something. You have you don't really think about how easy it is to mutate data inside a single transaction, and then you break it up, and you wind up with all these complications that you didn't or at least often are not anticipated. I don't know if there's any general wisdom that you ran into at Google or elsewhere around that.
Do other people have general wisdom about that? It's a really, really good question. I'm just curious what other people think.
Repeat the question.
The question is, sorry, I'll try to be concise. There are times when you want to factor out a service and you forget that it's doing some kind of ACID transaction or something like that on a relational database. And then it turns out that splitting it into two pieces breaks the transactional behavior or something like, there are many examples, and that's a mess. Yes. So I'm curious. Yes.
I've done that. So not so much at the data layer itself, but you just don't realize how much latency you're going to encounter when you start moving these microservices off. And like something that was a seamless transaction when the service was just talking to itself on the same server becomes something that's horrendously costly once you've taken that microservice and broken it out onto a bunch of different systems. And once again, when you start talking about multi-cloud, you start running into even more of those problems exasperated.
Yeah.
Randy? Only if you're looking for help, which you asked for. So if you have a transaction and you want to split it among services, you can't have a transaction anymore. So you want to think of it as a saga or a workflow. Right? Think of it as a workflow where I do step A transactionally in service A, I do step B transactionally in service B, and ditto C, ditto D, et cetera.
You can also use a queuing system in a situation like that.
I knew you'd have better answers than I did. Go ahead.
Actually, to follow up on the answer to that one, remind me of, I've actually never done it myself. It's more of a principle thing that I think makes sense, which is you create the logical transaction before you actually move it out. It's kind of like a dry run within the monolith. But anyway, I actually did have a question, which was, I was trying to trace backward from like the hippies versus bees thing, and you said at some point that the Epic infrastructure projects were built out of necessity. To elaborate on that necessity, was there such a demand for the Google product that the decision to do that initial investment was obvious? It's like, of course, we'll spend all this effort building the infrastructure because we have so much customers right now, and there's no way we'll survive. Wasn't that obvious?
So was it necessary to build all the audacious infrastructure? Well, customers, I mean, they weren't really making any money, I think, when they made that decision, but they, yeah, I mean, they felt strongly, and I think they were right, that a search engine that can index the entire internet will develop. I mean, PageRank is the eigenvalues of this matrix of links and so on, and you need to index everything, at least all the text, to do that. So if you want to index the entire internet and put it in a single place, they didn't have a place they could buy. I think they literally couldn't buy it, so they had to build it.
So from that answer, to me, that sounds more like something that was an intangible belief that they had, that if we are to succeed at that scale, we must do it. Not we are already at that scale. We must do it.
I see your point.
Okay, thanks.
Patrick.
I got one going back to the monolith breakup. In our experience, or in my experience of it, you don't break a monolith apart, you re-architect the monolith, workflows between it, which is why you have to deal with what you were talking about on the transactions and how the latency between it goes between it. And then I had a question for you, Ben. When you're moving all of this logic into the network layer, it's either a speed bump or a wall that I see coming up, is that you're taking explicit things out of the code and making them implicit, which kind of bifurcates the developer view of this. So I look at things and ask questions about, like, how do I know, in the network layer, how do I know something's retriable? Or how does somebody know that there is a timeout? And how do I cleanly separate that? And with tracing, which we're implementing Lightstep now, there is that still explicit part in the code that I can tie it together. Where do you see that working as we do move more logic out of the app?
That's a really good question. So how do you deal with things like timeouts and yeah, there are a lot of logical primitives that make sense locally that get complicated externally. Part of the Google internal system, there's this thing called util task that encapsulated a lot of these sorts of constraints, and it would propagate across the system and had beautiful properties where if you canceled something, it would propagate down, even downstream to services below you. Automatically through the RPC system and stuff like that. I just don't think that the industry is caught up to that stuff yet. I mean, that's kind of a dumb answer, but the context propagation piece is the most important. Open tracing was originally called distributed context propagation. I kind of wish we'd kept that name, because that's the point, is that I think context propagation has many purposes outside of tracing. And deserves to be treated as its own separate thing. One of the things I'd like to see done in that layer, at some point anyway, is this sort of logic. Like, we should be propagating things like timeouts through the system. So if you're way downstream and the person the process that initiated the request is long gone and you've long timed out, there's no reason you should proceed with the computation. And things like that are impossible without propagating context intelligently throughout the system. I feel like I should take one more question, then we should mingle and stuff.
Just continue on Patrick's question. Do you think that implementing your microservices functions or methods Idempotent will resolve and help basically with the retry mechanism and dealing with problems on the networking, particularly if you're running your services in a public cloud, let's say Azure or Google public cloud or Amazon, where network failures and network flops occur quite often?
Mm-hmm. So the question is around idempotency. Yeah, like, I love idempotent functions just like the next guy. But sometimes it's hard to do it. We actually had an engineer come to me. It's like, what's a good method name for an idempotent version of a method? Like, do it as many times as you want. Like, what's the right suffix for idempotent, because it's so hard to spell and no one knows what it means. Idempotency, if people don't know, is this idea that you can call something multiple times, and as long as it succeeds once, the effect doesn't. You can call as many times as you want, which is great in a distributed system. I mean, I think the fact you're asking a question means you're like an outlier in terms of your understanding of the problem. I think a lot of people don't even really think about it, for better or worse. But yeah, I mean, if you can restructure things to be idempotent, I think that's like an amazing win.
The recommendation is to try at least.
Right,
In a transaction situation where you could,
Yeah.
definitely make that.
I will say the people who are really the big brains at Google, the systems they designed were really simple. I mean, they would have to do it 3 or 4 times, but the final design is always really not that complicated, for these reasons, I think, if you got down to brass tacks. Anyway, this is really great questions. I feel like I should stop talking, but please come up and talk to each other, talk to me, whatever. But thank you so much for attending, and I hope you enjoy it.